Hi there, I'm Tamsin, and I'm thinking about what happens to metal when it goes in the sea. So I think we need to go to the seaside.
A trip to the seaside. Hooray! That is very rocky.
Problem is, we keep insisting on putting welded metal into the marine environment. We use metal on all sorts of things, on ships, on docks, on marinas, and we have a lot of problem with it corroding and with marine organisms getting stuck on it. And this causes us problems because it overloads the structures, puts holes in the structures, and can also block up pipes and drainage valves. You might have always thought the metal is shiny and smooth, but actually even metal off the shelf can have holes in it. Nickel aluminium bronze, or NAB, is particularly interesting because it contains a number of different metals. And these elements actually are in the NAB in different proportions in different areas. We call these phases. So an area that has lots of nickel will be like that blue phase, and the red one will have lots of iron. The red areas where there's lots of iron are susceptible to corrosion. When we weld NAB, we can make it even worse because we can change the phases around the weld. So we can increase the corrodability of the metal simply by welding it. This can mean that you get more corrosion, but it can also mean that corrosion produces more crevices, which will increase the biofouling too.
How do you fix corrosion?
We can use welding to mend corrosion. So if there was a corroded area here in this bit of NAB, you can see we've already cut it out, and we've cut this bit out here, and we also cut 2 grooves out here. And once we've cut the grooves out, we then need to mend them again, and we do that by filling them in with welds here. So this is basically a weld repair on a piece of NAB.
How does the sea get attached to the NAB?
So a lot of the marine animals start off really small, and they're actually floating about in the ocean looking for somewhere to attach. And they're feeling out for the chemical signals that are actually sent off by the very start of the biofilm and the bacteria that then attach. Once they start feeling these chemicals, they actually follow the chemical pathway to attach to the same piece of metal, and in that way you slowly get a build-up of a biofouling community, starting with the slime, then the bacteria, and then gradually you get the soft and then the hard shells. As this biofouling process continues, it can actually make corrosion worse, as the chemicals inside the glue that the organisms use to attach to the metal can exacerbate corrosion. Just last month, I finally managed to get some of my welded NAB samples into the marine environment. As you can imagine, this has been delayed. These are going to be there for periods of months and years, and we're going to use these as a way of investigating the corrosion and the biofouling and the interlink of these two processes on the NAB. In this way, my research hopes to improve the safety of ships and structures in the marine environment. Thanks for listening, and look out for me next year when I should have some more results.